Bismillahirrahmanirrahim. Assalamu alaikum. How dear students, I hope you'd be fine. This is Cambridge Lower Secondary Book 8 and today we are starting with chapter number 7, fractions. And we have done a lot about fractions in earlier grades classes and today we are going to do something different related to fractions. So let's see what are questions given. And fractions are basically used in everyday life more often than you might think. And one important use of fraction is in music, and you will find that a bar lasts a particular length of time measured in number of beats. Different types of musical note last for different number of beats, and this means that the number of notes that can fit into each bar depends on the type of notes. Okay, so you can imagine a bar like a cake. The number of slices notes into which it can be cut depends on how large the slices are, how many beats each note lasts for. Okay, so basically we use fractions when something is not in whole, okay, and we have to make parts out of it. So here in question number 1 it says use a written method to convert these unit fractions into decimals. We can convert fractions into decimals and vice versa. Similarly, there's one more method of expressing the numbers in fractions, and that is percentage. Okay, we will soon learn about it. So here it says use a written method to convert these unit fractions into decimals. Here we have 1 over 2, 1 over 4, 1 over 5, 1 over 6, 1 over 7. And then we have to figure that which of these fractions are terminating, that stops at a point, and which of them are recurring, repeats themselves. Okay, so first one, 1 over 2 has already been done, and you will find that it's a terminating decimal, that it stops at 0.5. It is not going any further. But when we talk about 1 over 3, so when you divide 1 by 3, you will find that it is 0.33333 and not stopping anywhere. So these sort of fractions are called recurring decimals. Let's figure that out of the given parts from C till K, how many are terminating and how many are recurring. So starting from 1 over 4, if we divide 1 by 4, we will put 4 outside. Always remember, we put the denominator outside. So we cannot divide 1 by 4. We have to put a decimal here, and it becomes 10. 4 2s are 8. Here comes 2. We'll again put a 0, and then 4 5s are 20. No remainder is left, so the answer would be 0.25. So it's a terminating decimal, right? Let's talk about 1 over 5. So when we will divide 1 by 5, it's 0.0, 5 2s are 10. Again, it's a terminating decimal. So we can write 1 over 5 is equals to 0.2. 1 over 4 is equals to 0.25. Let's check 1 over 6. When we will divide 1 by 6, here comes point. 6 ones are 6. 4 is the remainder. We'll put a 0. And then 6 6 are 36. Every time we will get 4 as the remainder, we'll put a 0 using the decimal. And we will then multiply it by 6 to get 36. And every time the remainder would be 4. So it is actually a recurring decimal. When we will write 1 over 4 and 1 over 5 are both terminating, right? But when we talk about 1 over 6, so 1 over 6 is equals to 0.166666. We can write it as 0.16 and dot over here. Okay, which expresses that 6 is a recurring decimal. So let's see about 1 over 7. When we will divide 1 by 7, it's 7 ones are 7. Oh, sorry. 7 ones are 7. Here comes 3, we'll put 0, and then 7 4s are 28. Here comes 2, 7 2s are 14. Here comes 6. 7 8s are 56. Here comes 4. 7 5s are 35. And then 5, we'll put a 0. And then 7 7s are 49. Here comes 1. And then again, this will repeat. Here comes 7, then 3, then 2, then 6. So it's actually, we can write 1 over 7 equals, you can check in calculator as well. It's 0.142857. 142,857, 142,857, so on. So these 6 digits are recurring. So it's a recurring decimal. It will not stop at any point. Now let's talk about 1 over 8. 8 ones are 8. 2 is the remainder. We'll put a 0. 8 twos are 16. Here comes 4. Put a 0. 8 fives are 40. No remainder left. So it's 0.125, and that's a terminating one. Next, we have 1 over 9. Let's check it out. 9 ones are 9. 9 ones are 9. 9 ones are 9. Every time we'll get 1 as the remainder. So it's actually 0.11111, so on. And that is a recurring decimal. Then 1 over 10. 1 over 10 equals to 0.1. We already know that. Let's check it out. Here it's 10. So we'll put a decimal over here. Sorry. It would become 10. 10 ones are 10. So it's a terminating decimal. Next, we have 1 over 11. We'll put 11 outside, 1 inside. But 11 cannot, 10 is not divisible by 11. So we have to put a 0. Here comes one more. And then 11 nines are 99. Here comes 1. Again, we'll put a 0, but it's not sufficient. So we have to put a 0 here. It becomes 100. 11 nines are 99. Again, here comes 1. We'll put a 0. Then we'll put a 0. So we can say that it's 0.090909. That's again recurring. And let's talk about 1 over 12. Let's find that if it is also recurring or terminating. Here comes 12. Put a decimal, becomes 0. It becomes 10, but 10 is not divisible by 12. So we have to put a 0 over here. It becomes 100. And then 12 eights are 96. 4. Put a 0. 12 threes are 36. Comes 4. 0. 12 threes are 36. So every time when we will subtract 36 from 40, we will get 4 as the remainder, and the chain continues. So it's again 0.083. Here comes bar, means it's a recurring decimal. That's all. Here comes question number 3, which says, here are 5 fraction cards: 5 over 8, 3 over 4, 7 over 10, 11 over 20, 3 over 5. Without doing any calculations, do you think these fractions are terminating or recurring decimals? So if the denominator is 8, 4, 10, or 20, or 5, let me tell you one thing over here. If we have any number that is 10, 100, 1000, or any multiple of 10 in the denominator. What are the numbers? 10, 100, 1000, or any multiple of 10 in the denominator. Then these sort of fractions will always be terminating. And since you will find that here we have 8, 4, 10 itself, 20, and 5 as the denominators. And we can easily convert these fractions, these denominators, into either 10 or 100 or 1000 or any other multiple of 10, like 10,000, 100,000, million, and so on. So if you look at 8, 8 is not a factor of 10 or 100, but it's a factor of 1000. 8 multiplied by 125 becomes 1000, right? So the number that could be turned into any of the multiples of 10, that is the numbers 10, 100,000 or their factors. If we will have any such number in the denominator, then the fraction would be terminating. Always remember that. Like if we talk about 4, so 4 times 25 is 100, it becomes 100. So 4 is a factor of 100, one of the multiples of 10. 10 itself is 10, and then 20. So 20 multiplied by 5 is equals to 100. It can also be turned into 100. And then comes 5. So 5 multiplied by 20 is 100. So since all of these numbers are either multiples of 10, either 10, 100,000 or any other multiples of 10, so they will always be terminating. Why? Because every number that has denominator 10 or its multiple can be easily terminated, right? So if we talk about 5 over 8, and also from the previous question, you can conclude this over here, that all the numbers here that have 4 or 5 or 8 or 10, these sort of numbers are all, since multiples, factors of 10, 100 or 1000 have terminating decimals. Okay, so now let's talk about these. Okay, so 5 over 8, when you'll divide 5 by 8, you can solve these fractions very easily by using a method that I'm telling you. Like, you just have to find their equivalent fractions. 5 over 8 equals 625 over 1000. So it becomes 0.625. 3 over 4 multiplied by 25. 75 over 100. And that's 0.75. You see? These are all terminating decimals. Again, 7 over 10. 10 multiplied by 10. Or you don't need to multiply it by 10. 7 over 10 is 0.7. It's again terminating. 11 over 20. 20 multiplied by 5. That's 55 over 100. So it becomes 0.55. 3 over 5. 5 multiplied by 20. It becomes 60 over 100. That's 0.60 or 0.6. Okay. So what would be the written method to convert the fractions to decimals? That's done. So all of these fractions would be terminating, and I told you the reason behind it. Because these are all the factors of 10 or any multiple of 10. Okay, that is 100,000 or so on. Then they are saying write the fractions in order of size, starting with the smallest. So since we have already found their answers, so the first one was 0.625. Second one was 0.75. Third one was 0.7. Then 0.55 and 0.6. Always remember one thing, whenever you have to compare the decimals, so what you have to do, you just have to write them down here vertically. Okay, 0.625. Here it's 0.75. We cannot compare them until and unless their number of digits after the decimal are same. So to make their decimals after decimal places similar, we just have to add the number of zeros. Here we have 3 decimal places, 2, 1, 2, 1. So what are we supposed to do? We'll add 1 0 over here to make it 3 decimal places. 2 zeros here, 1 0 here, and 2 zeros here. Now these are all like decimals. So we can easily compare them. And the first one is 625, the second one is 750, then 700, then 550, and then 600. So out of these 5 numbers, 550 is the smallest. So this one is the smallest, 0.55. Then comes 600, that is 0.6. It comes second number. Then 625, third. 0.700 fourth, and 0.75 750 fifth, right? So we can say that the first one would be 11/20 is the smallest. Then comes 3/5. D is the smallest. E is the second. Third one is 5/8. Fourth one is 7/10. And fifth one is 3/4. That's it, right? Next, we have question number 4, which says here are 5 fraction cards. Without doing any calculations, do you think these fractions are terminating or recurring decimals? So always remember, if we have denominators which are not factors of 10 or its multiple, like the factors of any multiples of 10, then the numbers would be recurring. And here you will find that 3, 6, 9, 11 or 12. None of these numbers are either factors of 10 or 100 or 1,000 or any other number, right? So we cannot make 12 into a 10 or 100 or 1,000 or a 10,000 or a 100,000 or million. No, we cannot turn it into any of these numbers. So these are all recurring decimals. Okay. So what method we can use to convert these fractions to decimals? It's here. If we have 5/6, so what are we supposed to do? We will divide 5 with 6 and we will get the answer. So let's see how are we supposed to convert these fractions into decimals. We'll put 5 inside, 6 outside. Here's 0. So 6 8s are 48. Here comes 2 down. The 0 6 3s are 18. And this will so on. Every time we'll get 2 as the remainder. We will then put a 0 with it. It becomes 20. Then multiply 6 with 3 and it becomes 18. So it's 0.83. We'll put a bar over 3, which shows that it's a recurring decimal. Like similarly, 2/3 is equals to, we already know that 2/3 is equals to 0.66666. So let's put a bar over here. Like 1/3 is 0.3333333. Similarly, 2/3 is 0.66666. Next, we have 7/12. So we will write 12 outside, 7 inside, put a decimal, and then 12 5s are 60. 12 8s are 96. 12 3s are 36. 12 3s are 36. 12 3s are 36. 12 3s are 36. So this becomes 0.583. Next, we have 5/9. 9 5s are 45. 9 5s are 45. 9 5s are 45. Every time we'll get 5 as the remainder, we'll put a 0 along with it, and then we'll multiply 9 with 5. So it gives us 45. So the answer to this one would be 0.555. We can write it over here. 5/9 is equals to 0.555. Now you have to find what will be the answer of 3 divided by 11. Okay. So next what we have to do, we have to write down the fractions in the order of size. So the fractions we have are 0.8333, 0.66666, okay, 0.583, and then 0.5555. And now I will not tell you the answer of 3 divided by 11, but I will only tell you that on which place will it come in this sequence. Okay. So if we look at the numbers, E is the smallest one. Let me tell you here. E is the smallest one. That is 3 over 11 is the smallest one. Then comes the second one is 583 or 555. Of course, 555. So it's 5 over 9. Part D is the second one. Okay. And then the third one is 583. That is 7 over 12. C. And then 0.66. Part B is the fourth one. And 5 over 6 is the largest. So it's EDCBA. That's all. So we have completed till question number 4. Inshallah, in the next video, we'll learn about more. Until then, take care. If you are new to my channel, don't forget to subscribe to my channel and share it with your friends as much as you can. Allah Hafiz.